This very short one-page lecture is a continuation of some reading we just had where I mentioned some of this. And what I really want you to know from this is just assembly language is, and the three pluses, and then but is also, and then three minuses, and then there are negatives. And then I'll just talk about some of the rest, but for this particular course, we're not learning to program an assembly language or developing an instruction set or anything like that, as we do in other courses. Just want to understand the main concept. So, high-level languages versus assembly language. So, assembly language is faster, uses less memory, better control over hardware since it directly translates one-to-one to machine code. But it's machine dependent, right, for a specific microprocessor or microcontroller. They each have their own instruction set. It's more difficult to program, need more lines of code, and you got to be very specific with your syntax. And even some assemblers, exactly where you put the code and exactly where that syntax goes on the code lines up in columns matters. Difficult to maintain, right? So those are three pluses and three minuses. Now, the rest here is just some enrichment you could think of on different types of applications. And typically, high-speed embedded kinds of applications for assembly language, and then high-level language, so pretty much all applications, high-level applications. Oh, yes, it says type of application, and then whether you use high-level language or assembly. I'll let you read through all that, but I would summarize, without even looking at the table here, that high-level language is for applications and for things where you need some complex coding. And assembly language is embedded systems where you need to be down near the hardware. You maybe need super fast speed. Maybe you don't even want an operating system. Good luck doing a high-level language without an operating system. Actually, I can think of a case where you could, but assembly language, no. It's meant to be compact and fast. And then down below here you see some examples of some high-level language, and then assembler, what that looks like. And this is just somewhat obscure references for you. The MIPS processor, you probably won't see that nowadays so much. Was very popular for a while. And then Fortran, I mentioned, that's historic. And then C and Java, now we do see those. So that translates down into some assembly language. And this is an understatement here, that in 4 lines of code you can do something that's in 3. I mean, you can have as many as 10, 20 lines of assembly language for one high-level language. I've seen that before. I've done that inside of IBM. And then the machine language is simply ones and zeros, but there's a direct one-to-one mapping. I mean, you can't really see it here, but if you take my course 332, Digital Design 1, in there, we begin developing an instruction set and a computer and the hardware at a gate level design level. You design it, and so then that's where you learn that, and then you actually learn how to program an assembly language in a follow-up course after that, 333. And then there's also 433, Advanced Computer Engineering. We develop instruction sets in there too, but those are typically even more advanced for vector register kind of machines, or neural network processors, or superscalar, multi-core, parallel pipeline, parallel processing machines. So first you got to get the fundamentals. This is just an introduction here, basic introduction.